Welcome. So in this video, we're going to be working through question 5 here. And it says, using the formula r is equal to the square root of a on pi, find the following correct to one decimal place. So we've been given this formula right here. R is equal to the square root of a over pi. So what exactly is this? Well, this r is my radius, and this a here is the area of a circle. I'll talk about where this formula comes from in a moment, but to answer these questions here, it's really just a matter of substituting in values. So here it says the radius of the circle with an area of 35 centimeters squared. So it wants us to find the radius if we have a circle of 35 centimeters squared. So how are we going to approach this? Well, let's just write out what our formula is. It's r is equal to the square root of a on pi. Now, we know, because the question tells us, that the area is 35 centimeters squared. So based on that piece of information, what we can say is that the area, or a, is equal to 35. And then what we're going to do is we're just going to substitute this information into our formula. So r is equal to the square root, and instead of a, I know that a is equal to 35, so we put that into that spot, and then pi. So what we're doing here, in this step, let me write this in orange, is let a be equal to 35, or we're substituting in this value for a. That's what we're doing. And now we have this. Now once we have this, this is when we use our calculator. So we bring up our calculator here. And what am I going to type in? Well, I'm going to go the square root. You click the second, then you hit this button right here. And just so you know, this calculator is your green calculator. It just isn't green. So let's just do that again. You hit second, you hit this button here, because when we hit second, it's just all of the values above that come into play. So we've got a square root there. Then I'm going to hit this button here for a fraction. Then I'll put 35 in my numerator, and then I'll put pi in my denominator. Then I'll hit enter, and I'll get 33.3377. Now it says correct to one decimal place, so that's going to be 3.3 centimeters. So now I'll come over here and I'll write in that r is going to be equal to 3.3 centimeters. And now we will just do the same thing for our next question here. So if I scroll down here, it says that the diameter of a circle with the area of 7.9 meters squared. Well, again, what I'm going to write down is just the formula that I know, what they've told me, that the radius is equal to the square root of a on pi. This time they're telling me that the area is equal to 7.9. So what that means is a is equal to 7.9. So we're just going to sub that value into our formula here. So we're going to get r is equal to the square root of 7.9 over pi. Then we would come to our trusty calculator here. Again, you hit second, you hit this button, you hit that button, then you go 7.9 over pi, which is there. We hit enter, and we're going to get out as our answer 1.585. Okay, so now we come here and we go, r is equal to 1.585. And the reason why I'm giving you a bit more extra decimal places here is because we're not done yet. Because they've asked us for the diameter, but we have the radius here. Well, we know that all we're going to have to do is multiply this by 2. We're just going to find what 2r is, because 2r is going to be my diameter. Because remember, if we think of a circle, that's a pretty ugly circle. Let's try again. If we think of a circle, that's pretty good. We have the center, and this right here, that's my radius. But then this is my diameter. So that's just another r. So my diameter is the whole thing there. It's the whole thing. It's 2 r's. It's a pretty ugly drawing, but you get it. So what we're going to do here is I'm going to take this. I'm just going to go times 2, enter, 3.17. Remember, we're rounding to one decimal place. So this 7 would round up this 1 to a 2. So that means I'm going to get, I could say 3.17 here, but then my final answer would be 3.2. So I'm just providing my final answer, the diameter, to 1 decimal place because that's what it asked us for. So that's my final answer there. D is equal to 3.2. All right, that is how you answer this question. So that's everything you need. But I just want to pause before we leave this question and actually talk about where we got this formula from. So let's get rid of my calculator here. Let's get that out of here. Get out of here. And then what I'm going to do is I'm going to grab this color here. And we're just going to talk about how we got this formula here. Like, where did this come from? So where did it come from? Let's start off by writing what we know, that the area is pi r squared. And can you see here that this one, the r is equal to this. So r is by itself. So could I rearrange my formula here so that r is by itself? And I absolutely could do that. The first thing that I could do is I could divide this side by pi and divide this side by pi. And if I was to do that, this pi would cancel with this pi, which means I'm going to be left with, on my left-hand side there, a on pi is equal to r squared. Now this is where it becomes tricky, because we're going to have to say to ourselves, well, I want this r by itself, but at the moment it's being squared. So I need to undo this squaring. So I'm going to have to undo something to both sides. In the same way as up here, the reason why I divided by pi was because I'm doing the opposite operation to what this pi was doing to this r. It was going pi times r squared, right? So we, instead of multiplying, we divided. Well, we're going to do the same thing here. We're going to do the opposite of squaring to get rid of this squared here. And to do that, you'd have to square root both sides, because that's the opposite. Whoops. That is the opposite of squaring, to square root something. So I'm going to do that. And then once I've done that, what I'm going to be left with here is the square root of a on pi is equal to r. And of course, I can just rearrange this now. R is equal to the square root of a on pi. It's the same thing. I'll just put this on the other side. So this is kind of the logic of how we start with our general area formula, and we can rearrange it now to find the radius, which is pretty cool if you ask me. All right, and that's all I really had to say. The most important thing is that you can generate these answers here, this one and this one. And this is just showing you how we got them. Hopefully you found this useful, and I'll see you in the next one.